In 1970, a mathematician wrote a paper that would design the next 50 years of computing. His own company read it and buried it. On purpose. Not because it was wrong. Because it was right, and being right would kill a product they were making very good money on. So he went around his own employer's back, straight to the customers, and let them do the shouting. That's how the database you use every single day got out of the building. Last time we climbed down into the backend, and over we watched the server do one thing, write something to a database, pull it back out. Where did it go? We called it somewhere, waved our hands, and kept walking. Today we open that box. Welcome to Region 3. Nickname: the Materials Warehouse. And there's one story we're chasing, not a list of products, but a single question, asked for 60 years straight. How do you stack your stuff? Every time the answer changes, the whole industry moves. Rewind to the late 50s. Computers show up at companies and people store data the most obvious way a human can imagine. Files. Customer list in a customer file. Orders in an order file. And it worked fine. There wasn't much data. Then the warehouse filled up, and it cracked in exactly 4 places. 1. Duplication. A customer's address is in the customer file, and also in the order file as a shipping address. He moves? You're fixing it twice. 2. Inconsistency. What happens when you fix one and forget the other? File A says stock is 100, file B says 80. Which is true? Nobody knows. And the moment 2 ledgers disagree, the warehouse has lost your trust. 3. Search. Today you hit Control F. Back then there was no such thing. To find one customer, you wrote a separate program that walked the file line by line from the front. No tags, no signposts, just marching from the entrance to the back wall, lifting every crate. And 4. 2 people open the same file, both edit, both save, and only the last one survives. The first person's work is simply gone. Now, were people back then stupid for using files?
No.
Files are still a fine answer. Small data, no fancy search, and a spreadsheet is often exactly right. Files didn't collapse because files were bad. They collapsed because the data outgrew them. So in the early 60s, the first real answer arrives: the hierarchical database. Company on top, departments under it, employees under those. A tree. IBM's flagship was called IMS, and for its time it was a genuine leap. And where did IMS come from? This is my favorite fact in the chapter. It was built in 1966 to manage the parts list for the Apollo moon landing, every bolt on the rocket that put humans on the moon. Then it came home, took off the spacesuit, and spent the next several decades filing corporate invoices. Remember the name IMS. In 5 minutes, it becomes the villain. But the tree had a fatal flaw. You could only move up and down. Ask a vertical question, company, department, employee, and it's brilliant. Ask a sideways one, like every project this person worked on, and it chokes. One employee spans many projects. One project holds many employees, and a single branch cannot say that. So people built the network database, which drew lines sideways too. Not a tree, a web. More flexible, absolutely. But to pull one item out, the programmer specified the route by hand. Follow this line, then that one, then turn here. They'd punched passages in every direction, and the price was carrying the whole maze map in your head. Then June 1970. One paper flips the table. An IBM mathematician named Edgar Codd publishes a relational model of data for large shared data banks. And the core idea is so simple it's almost insulting. Just store the data as tables, rows and columns. No maze, no tree. But the table was never the point. The point was behind it. Let people pull the information they want without the faintest idea where it physically sits on a disk. That's data independence. That maze map the network programmer memorized? Codd wanted to burn it. He installed the first standardized shelving. You don't memorize routes. You just say the label. And here's where it gets ugly. Cod wrote that paper fully expecting to make an enemy of his own employer. And he did. IBM was making excellent money on IMS, the hierarchical one, and flatly refused to implement the relational model. So he gave up on the executives and demonstrated it straight to IBM's customers, who promptly turned around and started pressuring IBM. Not innovation handed down from the top. A revolution shoved in the front door by the paying customers. When IBM finally launched System R, they kept Cod at arm's length from it, and he eventually left. And before all this, he flew flying boats for the Royal Air Force in the Second World War. The father of the modern database started out in a cockpit. So what does a table look like? A row is one record, one customer. A column is an attribute, name, phone, email. Orders get their own table, and crucially, that table does not copy the customer's name and address. It writes one number. The owner of this order is customer 7. Who's 7? Look it up next door. Lining two tables up by matching tags is a join. Now, about the name relational. Almost everyone assumes the relation means the lines connecting tables. It does not. Cod took the word from set theory, where one table, by itself, is the relation. So we have been misreading the most important word in databases for 50 years running. One of the great naming disasters of our field. The language you use to talk to these tables is SQL, and its charm is that it reads like English. Want the names of every customer 30 or older? You write, select name, from customers, where age is 30 or greater. Read that out loud. It's a sentence. And that was deliberate. The designer, Donald Chamberlain, said the goal was to make it read as close to natural language as possible, so non-experts could ask questions of their own data. One more thing, because people mix this up. SQL is not the database. It's the language you shout at the database, and the same sentence works in Oracle, MySQL, and PostgreSQL. So how do we kill those first two nightmares, duplication and inconsistency? The cure has a scary name, normalization, and one line of meaning. Store each fact in exactly one place. The address lives only in the customer table. Everything else points at it by number. The guy moves, you fix one cell, you're done. Normalization comes in stages, and please don't memorize them. Just feel the direction. Higher stage, harder squeeze on duplication. First form, one value per cell. No cramming, hiking, fishing, reading into one box. Second and third, anything that doesn't truly belong to the key moves out to its own table. Most services stop happily at the third. And the blueprint deciding in advance which columns exist and what type each holds is the schema. Shelf specs, nailed down before anything goes on them. There's a tragedy buried in that word, normalization. One of the stages we casually use is Boyce Cod normal form, and that Boyce was Raymond Boyce. At IBM San Jose, he co-wrote the paper that became the prototype of SQL, and with Cod, the normal form that carries his name. And then, the very year that paper came out, June 18th, 1974, he died of a ruptured brain aneurysm. He was 27. He left a wife of 5 years and a 10-month-old daughter. In under 2 years, he raised 2 pillars of the data world and never got to watch his language change anything, not for a single day. So, every developer who normalizes a table is quietly saying his name every day without knowing it. 3 products carry this idea. Oracle, founded 1977, has held up banks and governments for decades. Powerful. Expensive. MySQL, open source from 1995, rode being free through the web era like a rash. PostgreSQL came out of Berkeley Research, a notch above on stability, and lately it's surging. All 3 are CODs stored as tables in different jackets. And speaking of Oracle, here's how the universe settles accounts. In 1977, a young Larry Ellison read Cod's paper, got inspired, and started a company on it. It made him one of the richest people alive. Meanwhile, the man who wrote the paper was being ground down by internal politics until he walked out. Same document. For one man, a ladder. For the author, a lifelong fight. Two things were still missing before this warehouse could be trusted. Don't be wrong, and don't be slow. Don't be wrong is transactions and ACID, and we climbed that ridge back in region 2. One flag only. ACID is how a database institutionalizes its defense against the exact nightmares of the file era. So, don't be slow. Remember problem 3, scanning from the front? Once a table hits 1,000,000 rows, hopeless. Enter the index. And the best analogy is the index at the back of a book. You want the word backup in a thick manual. Start at page 1 and flip, or open the back, where it says, Backup, page 287. One line and you jump. A signpost built ahead of time, so the search leaps instead of walking. Nothing is free. An index makes reads faster, but every new row means updating the signpost too, so writes get slower. Which leads to the trap that gets everybody more indexes means faster, right? The exact opposite. Put up 100 boards, and every item arriving means correcting 100 boards. Spray indexes across a write-heavy service, and the thing you installed for speed is now the anchor dragging behind you. And there's more than one kind of signpost. B-tree is the workhorse, good at ranges and sorting. Hash only does dead-on exact matches, but blindingly fast a locker number. Full-text hunts for words buried inside long text. COD proposing tables in 1970 was theory, and theory is not proof the thing runs fast. The doubt was loud. Clean on paper? Sure, but will it keep up with IMS? Two projects broke that doubt on opposite coasts. In the East, system are at IBM, San Jose. In the West, Angra at Berkeley, built by Michael Stonebraker in 1974. Two camps racing to prove the same theory in working code. Stonebraker later built a system he named Postgres, meaning post-Angra, the distant ancestor of PostgreSQL. And the feud was petty in the best way. SQL's original name, SQL, is widely taken as a pun poking at Berkeley's query language, QEL. It resolved with Turing Awards for both of them. So that's the relational world, rock solid for 30 years. And then in the mid-2000s, the board shakes. The internet detonates. Google, Facebook, Twitter. What changed wasn't the idea. It was the sheer volume. Facebook processes tens of billions of likes in a day. And here's where relational hurts. It gets bigger by making one server beefier. Move to a bigger warehouse. But one building has a ceiling no matter how tall you build. So you split across many servers, and now the shelving turns on you. Stitching tables back together with joins across 100 machines gets slow and horrible. So a new camp forms, NoSQL. The name means not only SQL, stop insisting on one language. And the trade is blunt. Give up some accuracy. Get scale and speed back. Throw out the standardized shelving and don't even predefine the slots. That's schemaless. Throw it in first, shape it later. And NoSQL isn't one thing. It splits by what you stack instead. Document stores like MongoDB keep freeform notepads, good when the format keeps changing. Key value stores like Redis, our Sicilian friend from last time, keep one value per name tag in memory for blistering speed. Cassandra spreads mountains of data across machines and swallows writes for breakfast. And graph stores like Neo4j store the connections themselves for friend of a friend. The history of the word NoSQL is a plot twist. It was first used in 1998 by Carlo Strozzi as the name of his own relational database that just didn't happen to use SQL. So the original NoSQL was relational. Today's meaning got locked in 11 years later at a 2009 meetup in San Francisco, where Eric Evans suggested NoSQL as a Twitter hashtag for the event. The hottest database camp on Earth is named after a hashtag for a meetup. And the conclusion of this whole chapter is that there is no single right answer. A bank cannot be off by 1 cent, so it stays relational. Social media survives a like count being briefly off by a hair. What it cannot survive is failing hundreds of millions of people at once. Depends entirely on what you're hauling. But not everything piling up here comes in tidy rows. Photos, videos, PDFs, bulky cargo you cannot line up on a shelf. Not a database's job. There's a separate holding area for it called storage. And here's the mystery for the rest of this lecture. A database and storage are total strangers. So, why does the AI recommend a tool where the two of them live under one roof? First, the naive version. Everybody starts the same way, a folder on the server called upload. Dump the files there. Store just the path in the database. 3 fatal cracks. 1. The server dies, the files die. 2. Add more servers and nobody remembers which machine a file is on. 3. When thousands want the same popular photo, the server is too busy shipping it to do its actual job. And a backup patches crack number 1. 3 cracks, 1 patch. Meanwhile, something else was changing about the database itself. Before the 2010s, a database was something you installed. Now it's something you use. That one word changed everything. The old way. Rent a server, install the software by hand, tune it, secure it, patch it, back it up, expand it when it overflows. All by hand by a human. There was an entire job title for this grinding housework, the DBA. You hired a warehouse keeper just to keep the warehouse standing. Then the cloud companies said, that housework? We'll do it. Now, here's a word people get wrong constantly. Serverless. It sounds like there is no server. There is absolutely a server, humming in a data center right now. What vanished is your obligation to think about it. Like electricity, you plug into the wall, you don't build a power plant in the backyard. And no, serverless is not automatically cheap. It's quiet cheap and loud expensive. Pay for what you use means a traffic spike hands you a bill with an extra digit. Why did this erupt when it did? Because in the late 2010s, Frontend developers exploded in number, and every one of them, just to touch a database, had to stand up a backend server, build an API, and implement login themselves. So what developers wanted was embarrassingly simple. Give me a database. Almost no setup. Throw the login in. Hold on to that thirst. And the first one to try wasn't who you'd guess. Firebase, which started life in 2011 as a chat startup called Involve. The founders watched developers use their chat engine to sync game scores in real time instead of, chatting. So they ripped out the sync engine, threw away the chat, and shipped that back to the files. Amazon answered the pull it out of the server problem on March 14th, 2006, with simple storage service, S3. The pitch, file storage? Hand us the whole job. And the tagline was the product's identity in 3 words, storage for the internet. Upload a file, and Amazon scatters copies across multiple servers on its own. One server explodes, your file is fine. The published durability, the odds it never disappears, is 11 nines. Hand them 10 million files and, on average, you might lose one in 10,000 years. This kind of storehouse is object storage, and it doesn't think the way your laptop does. No folder inside a folder inside a folder. 3 concepts. A bucket is the warehouse, an object is a file inside it, and a key is that object's name. And the key hides a trap that has burned a lot of people. You write a key like users/123/profiled JPG, and those slashes are not folder dividers. They're just characters. One single-line name tag wearing a folder costume. The console draws it folding and unfolding like directories, which is a lie told out of kindness. And those 11 nines aren't a marketing invention. Every file is stored redundantly across at least 3 physically separated data centers, split into fragments, so the original rebuilds even if pieces rot. The system verifies stored data billions of times per second and repairs disks before they fail. Propping up all that swagger is a system that is, frankly, deeply paranoid about itself. So, who designed it? Alan Vermeulen. In 2004, Amazon granted him a one-year internal sabbatical. He put down his manager job, went back to being a single engineer, and spent the year designing S3. What came out was a 6-page proposal that became the blueprint. And his real achievement was inventing nothing. The industry was sunk in a heavyweight protocol called SOAP, and his team threw it in the bin and built on the two simplest operations the web already had: put to upload, get to fetch. Oh, and a good chunk of that historic document wasn't written in a conference room. It was written at a pub on Capitol Hill in Seattle called Six Arms. By his own account. Opened the laptop, drank plenty of Hammerhead ale, and worked out what the design ought to be. And the product manager on this thing? Jeff Bezos. Not the CEO who approved it, the actual PM. He met the team twice a week, challenged every idea, pushed them to think bigger. Vermeulen later credited the success to, quote, a fantastic PM, Jeff Bezos. His vision was one sentence: give everyone the tools that let a college student in a dorm room start a company. Which is why the cozy story you've heard, that AWS started as a way to rent out spare servers in the off-season, gets flatly rejected as a myth by the people who were there. The real starting point was an internal vision document in 2003 calling for standardized, automated infrastructure. Storing files safely, solved. But storing and delivering are two different problems. Your original sits on a disk somewhere in the United States. A user in Korea asks for that photo, and the signal crosses the Pacific and comes back while the screen just spins. The storage is perfect. It's just slow. The fix is a CDN. Copy the file in advance to outposts around the world: Seoul, Tokyo, New York. Those nearby copies are edge servers, and now the Korean user grabs the photo next door instead of flying to America for it. If S3 is the warehouse, a CDN is the corner shop on every street. And delivery got solved before storage did. In 1995, Tim Berners-Lee challenged MIT to solve the exploding congestion of the internet. That research became Akamai in 1998, 8 full years before S3. And Akamai is Hawaiian for clever. Right behind delivery comes access control. Files get a grade. Public, anyone with the URL sees it, fine for a profile picture. Private, nobody just gets to look, which is what a payment receipt or a medical image needs. But sometimes you need to show a private file to one authorized person briefly. That's a pre-signed URL, a temporary address with an expiry, 10 minutes say. It's a movie ticket, valid for that time, that seat, and after that a worthless scrap of paper. And don't fall for the alternative. I'll just make the URL really long and hard to guess. That's not security, that's a costume. Once it leaks into a browser history or a log, that URL is a key that works forever. And here's a modern iron rule, tattoo this one on. Never put image files in the database. A database is built to handle text, numbers, and short addresses, fast. Cram photos and videos in there, and the whole warehouse crawls. Bulk goes in storage. One line, the URL, goes in the database. Let's walk a single photo through. You pick a photo on your phone. It goes to the server, which pushes it up to storage. Storage creates a URL and hands it back. The server saves that URL, not the photo, into the database. Later, someone opens the post. The URL comes out of the database. The screen requests the image, and the CDN serves it from the nearest edge. Data on one side, files on the other. So now the two rivers meet. The thirst from earlier, easy database, login included, real-time updates, and everything we build up about storage converge on one point. Firebase got there first and bundled all of it into one package, but with two limits. Its database was NoSQL-based, awkward the moment your data is genuinely tangled. And it isn't open source, it's Google's, so if you don't like where it's going, you can't leave. So in 2020, Supabase turns up shouting, as easy as Firebase, but on a proper SQL database. And its heart is PostgreSQL, the orthodox relational database from the first half of this lecture. Stonebraker's descendant. COD's standardized shelving. Under one roof, it puts the database, authentication in a few lines, storage on the same object structure as S3, an auto-generated API, and real-time updates. Why did three total strangers end up sharing a house? Because in the old days you set up all three separately, every cloud vendor did it their own way, and you handwrote the glue holding them together. That glue was the barrier to entry. Supabase ships all three pre-wired. That's the entire reason the AI recommends it the second you start vibe coding. And notice the pattern, because it's the joke this whole region keeps telling. Firebase was a chat startup that accidentally became a backend. Supabase exists because its co-founder slammed into a limit, one write per document per second, and went looking for a way around it. S3 was drafted in a pub over an ale. Nobody in this story set out to build the thing they're famous for. The path always opens from a side road. All right, look at the ridge we just climbed. 60 years of one question. How do you stack your stuff? Files piled on the floor until 4 cracks opened. Duplication, inconsistency, unbearable search, and people overwriting each other. Then a tree that could only look up and down. Then a web that made you memorize the maze. Then COD installed standardized shelving. Just store it as tables. Join linked the shelves by matching tags. Normalization killed duplication by keeping each fact in one place. And the index bolted a location board to the entrance. Then the warehouse outgrew the building. NoSQL traded a little accuracy for room to spread across many warehouses, and the answer to which one is still forever depends on the cargo. Meanwhile, the bulky freight moved out entirely, files off the server into object storage, delivered from an edge nearby, handed out on tickets that expire. And finally, the database, the storage, and the login stopped being strangers and moved in together. And notice, not one of these was a term you had to memorize. Every one was a scar left by a specific problem. Ledgers disagreed, so normalization appeared. Search crawled, so the index appeared. One building hit its ceiling, so NoSQL appeared. Files died with the disk, so object storage appeared. Hold on to what was hurting, and you can read any warehouse you ever walk into. Everything you just learned is Region 3 of a book called The AI Development Atlas. 10 regions, 1 map. The front end you can see, the back end you can't, the warehouse underneath both, and 7 more ridges beyond. It's written so you can command the machine instead of riding shotgun while it drives. Because here's the payoff. Say, build me a database, and the AI guesses. Say, this is payment data, so make it relational with transaction guarantees. Split customers and orders into separate tables referencing by customer number and index the email column. And you get the warehouse you actually wanted. Its tagline says it best. Only those who know the terrain can command the AI. This has been a DK-Corp production. We build the maps so you can command the machines.